Hello there, welcome back to the CS School channel. In this video we are going to look at wave sort array problem. Okay, so this problem is asked a lot of time in different coding interviews. I have added link to this problem in the description of this video, so do check it out and try to solve it on your own. If you can't solve it, come back to this video. So let's look at the problem statement which is given on the screen. Given an array A of integers, we need to sort the array in a wave-like form. So now what is this wave-like form? So wave-like form means this form, where the first element of array is greater than or equal to the second element. The second element of the array is less than or equal to the third element. The third element of the array will be greater than or equal to the fourth element. The fourth element of the array will be smaller than or equal to the fifth element, so on and so forth. So hope you got the problem statement. So here are some of the sample inputs and outputs for the problem. Okay, so the input array which is given to us is something like 1, 2, 3, 4. So after changing this array, we have converted into a wave-like form. So the first element is greater than or equal to the second element, right? The second element is smaller than or equal to the third element. The third element is greater than or equal to fourth element. Okay, similar thing happened in this array. Okay, here is the third example array, which is little bit longer array. Okay, the first element is greater than or equal to the second element is smaller than or equal to the third element is greater than or equal to the fourth element, and so on and so forth. So is there any approach you can think of for solving this problem? The first approach I can think of is after sorting the array. Okay, so let's look at what happens after sorting this array. So suppose we are given this long array. After sorting it, we can be sure that the first element will be smaller or equal to the second element. The second element will again be smaller or equal to a third, so on and so forth, right? So what happens if, let's say, we consider the first four elements, this 2, 3 and 5, 6. Okay, so in our wave sort, we want first element to be greater than the second element, right? So what we can do, we can swap these two numbers. So now after swapping, the number becomes 3, 2, 5, 6, right? So see, first element is greater than or equal to second element is smaller than the third, right? But we want third element to be greater than fourth, right? So what we can do, we can swap these two numbers again. So we can do something like this: 3, 2, 6, 5. So see now, first element is greater than second element is smaller than third element is greater than fourth. We will repeat this action on all pairs of numbers and we get finally our wave array. Okay, so hope you got the intuition behind this approach. Now let's see this approach. So in this approach, we first sort the array and we swap all the pairs of numbers. Okay, we start with 0, we swap the pair 0 with 1, okay, and we jump to the next pair, which is the element on the second index. Okay, so what we will do, we will start with this 2, 3, we will swap them with each other, that gives us 3, 2. Okay, then we jump to this 5, we swap 5 with 6, so 6 comes at the position of 5 and 5 goes to this position of 6. Similarly, we jump to the next pair 2 and 20, we swap them with each other. Then we jump to the next pair, which is 80, 100, we swap them with each other, and this gives us final wave-like array. Okay, so first element is greater than or equal to second is smaller than or equal to third is greater than or equal to fourth, so on and so forth. Okay, so what is the time and space complexity for this approach? Well, as we are sorting the array, that gives us the time complexity of O of n log n, right? And after that, we are running just one for loop in which we are swapping the array. So that gives us the time complexity of O of n. So it is maximum of either this or this. So the time complexity is O of n log n. Okay, and what is the space complexity? As we are not using any extra space, we have the space complexity of O of 1. Okay, so hope you got the sorting approach. So if you give the sorting approach to the interviewer will be happy, but he or she will ask you to optimize the approach. So what we can do in this problem? Well, if you think hard enough on this problem, you can actually find an approach where we don't need the sorting. Okay, so what we can do, we can actually process this array in the combinations of 3. So let me take an example, like this is the first element in this combination. So ai minus 1, this is the second element in this combination ai, and this is the third element in this combination. So basically we will process this array in the combinations of 3, right? So what we want actually, So AI minus 1 should be greater than or equal to AI, right? And the another condition that we want is AI should be smaller than or equal to AI plus 1. Okay, so suppose AI minus 1 is not greater than or equal to AI, then what we can do? So we can swap AI with AI minus 1, right? And that will basically satisfy this condition that AI minus 1 is greater than AI, right? And what happens if AI is not smaller than AI plus 1? Then you can swap those two numbers again, right? And that will basically satisfy this condition. Okay, so hope you got the intuition. So basically we just need to process this array in a combinations of 3, and we need to just swap the numbers if the conditions are not satisfied. So hope you are clear with the intuition behind this approach. Now let's look at the approach. So basically we have run a for loop which will start with 1 and which will go till n. Okay, in each of the iteration we check if array of I minus 1, so basically the first element is less than array of I. The first element should be greater than array of I, right? Well, that's the case, then we swap the array. And then we check if I is less than n minus 1. We need to add this to check the overflow, okay? And then we check if array of I, the second element, is greater than array of I plus 1. Actually, this should be smaller than I plus 1, right? If that's the case, we just swap the two numbers. So basically in this approach, we check the combination of 3s in the array and we swap the numbers according to our conditions. So hope you got the approach. Now let's see the step-by-step iteration of this algorithm. So suppose we are given an input array which is shown on the screen. Okay, so what we will do, we will start processing this 5. So we will check whether the first number to this 5 is smaller than the current number, right? Well, that's not the case. The 10 is already greater than or equal to 5. Then we check whether this 5 is greater than 6. Well, that's not the case either, right? So 5 is already smaller than 6. Then we jump by two numbers and start processing these triplets. Okay, we check whether 6 is greater than 3. Well, this is the case, right? 6 is already greater than 3, right? So we don't need any swapping. And then we check whether this 3 is greater than 2. Well, 3 is greater than 2, right? So then we need the swapping. So 2 comes at third position. So now this triplet is satisfying all the conditions. Basically, first number is greater than or equal to the second, and second number is smaller than or equal to third, right? Then we jump by two numbers and we start processing these triplets. So basically we check whether 3 is smaller than 20. Yes, this is the case, right? Then we swap the two numbers. So 20 comes at 3's position, 3 goes at 20's position. So this is the output. And after that we check whether 3 is greater than 100. Well, that's not the case, right? So we don't need the swapping. And then we jump to the next triplet, this 80 and 100. Basically in this iteration we check whether 100 is smaller than 80. Well, that's not the case, right? So we don't need the swapping and we keep the numbers in the exact same positions. And at the end we just return the array. So hope you are clear with the step-by-step iteration of this algorithm. So what is the time and space complexity of this approach? Well, we are just running one for loop over the entire array. The time complexity becomes O of n, right? And what is the space complexity? As we are not using any extra space, the space complexity becomes O of 1. So now let's look at the C++ implementation for the approach. So we need to complete this wave function which takes vector of integer as an input and it expects vector of integer as an output. So in this function we have first run a for loop which starts with 1 which go till size of the array, and in each iteration we increment the I by 2. And we check if a of I minus 1 is less than a of I. If that's the case, we just swap the two numbers and we again check if a of I is greater than a of I plus 1. Then again we swap the two numbers. And at the end we are just returning the array. So now let's run this code. For running this code, I have written a main function in which I have declared a vector of integers and I have passed that vector to the wave array function. And after that I have just printed all the elements of the array. So let's run this code now. So at the end we get the wave array which is our required output. So hope you are clear with the problem and its solution. If you have any doubts, please ask me in the comment section. I will be more than happy to help you. We will be making more such videos in the future, so stay tuned for further videos.